Okay, so in this video, we're going to talk about how to create a table inside a database. Okay. Now, we will have, in another meeting. In fact, uh, next meeting, not this current one, we're going to have a discussion on how to determine which tables you need to create inside a database. But let's have a basic understanding that a database may contain one or more tables. How you would know which tables you'll create inside the database, that depends on basically like a brainstorming uh, process that you have to go through prior to you actually sitting down in front of the computer and building the database. Okay. Now, so for the purpose of this example, uh, we're gonna assume that we've gone through that process. Okay. Also, just want to point out that I have MySQL. Yeah, MySQL running. Yeah, I also have the workbench running, and I just have here the reference to basically the MySQL manual already open. All right, so let's begin. I'm gonna create a new query tab in workbench. Let me zoom in so you can see what I'm typing. Okay, now the situation is I'm gonna use this school database to contain my students table. Let me show you this PDF file that I prepared. So this is the table that we're gonna create inside the school database. It should be capable of storing, well, it's not a way to put it, student information, basic student information, student ID, first name, last name, and email address. Now, so in other words, from the brainstorming process, we figured that well, we're gonna need four columns, or we're gonna need to store four things about the students, or about each student. These four columns are effectively your fields. So essentially we have we need four fields in this table. Do not worry about in the beginning. Do not worry about, oh, how many rows will my table have. That's not something that you should be worried about in the beginning. How many rows you're going to have in your table depends on how much data you're going to dump into that table later on. But in the beginning, what you should be concerned about is what will be the fields in your table, and what will be the settings of each field, each column. Okay. All right. So to actually make that happen, to make the table, we're going to need the create table statement. Okay. And as you can see, the syntax of it quite lengthy. All right. So don't worry. I'm going to boil this down to you. In fact, we won't have time to cover all of these, but I'm going to point out to you quite a few things that are key in creating a table. Okay, so for starters, we got the school database. Now, one would think, or probably you're thinking, so it's just a matter of typing create table here. Actually, that's the wrong move. Here's why. Even though you have a database already made over here, okay, you have to indicate to MySQL uh, inside this, let's say in this case workbench, and even when you create your apps or websites, you have to indicate which database in the MySQL server you want to use. So to make that happen, because right now, if I go ahead and create, just to show you the point, all right, so I'm going to create a table. I'm going to call it um, dummy table. Okay, so according to the syntax, create table, type the name, so I'm calling it dummy table. And there are three sections here: create definition, table options, partition options. Okay, so let's focus on create definition. If you noticed here, we have to put a pair of parentheses. Okay, so I'm gonna put parentheses there. In fact, I'm gonna put that towards the end. And So create definition false on this line, and in fact it says create definition, okay, is composed of a column name, okay, so that we know already, and column definition. All right, so what's a column definition? Column definition will be composed of the data type and a few other settings that you want to put in. All right, so just for the sake of demonstration, so I'm going to call this column call1, and I'm going to give it what's called a data type, which don't worry, I'm going to discuss it later. I'm going to call it int, and I'm going to put a semicolon at the end. So that makes that a valid statement. So I'm going to go ahead and run it. Okay, excuse me. All right, so it says here I got an error. Now, as you can see, it is syntactically correct. I mean, though it's very incomplete in terms of structure, but with regards to the statement, its correctness, it is correct. So how come I'm getting an error? Okay, the reason for that is this. Okay, I did not specify which I didn't specify which database I want this table created in. Okay, so that's why this is not working. All right, so let me get rid of that. So what are you supposed to do first? Assuming you have the database already, how do you create a table in it? Well, you have to tell MySQL which database you want to use. So you have to type use school, or whatever the name of your database is. So the use statement, okay, allows you to tell MySQL, hey, I want you to focus on the school database. That any table I'll create, anything I'll do from this point after I run this will um, will be towards the school database. All right, so I'm going to run this. As you can see here, there's a check mark, says use school, zeros affected. But um, with that, we're now sort of inside the school database. Okay, so in fact, after I ran it, these automatically came up. Not that that's always going to happen to you, you know, when you put your statements inside a program or an app, but just letting you know that you know something happened when we ran after I ran the statement. Okay, so this is important. And by the way, if I want to put a comment here, say above, yeah, I can put a comment. You can put you normally put comments in your code. Comments are notes, okay? So comments are notes in your code. That's either for you or for other people who's going to read your code. So if you want to put a comment, you can put comments above the line or above the chunk of code that you're commenting on, or say towards the right. Okay, so usually those are the places where you want to put them. So for example, in MySQL, just like what I said in the lecture, there are three ways. If you're doing a single line, or let's start with a multi-line comment. A multi-line comment in MySQL or MySQL, also Microsoft SQL Server, and also Oracle. These three large or popular database systems, you can put multi-line comments by starting your multi-line comment with a / asterisk. Now you can type as many comments as you want, as much comments as you want. So for example, um, uh, author is Joel Amradi, email ja2029 at hunter.cuny.edu, and close it. And that pretty much is a multi-line comment. It's called a multi-line comment because, as you can see, it spans multiple lines. Okay. Now, if you want a single line comment, you can do that too. For instance, I can put one here, begins with hyphens, two hyphens, 1, 2, and then I can type the comment that I want. After that is a use school database. Okay, so I can type the single line comment preceded by two hyphens. I can also, and by the way, I don't have to put that there. I can put the comment over here. Okay, so I can put the comment to the right of the code, and there you go. So I have two hyphens. I can also, in MySQL, I can put a pound sign, and it'll do the same thing. Okay. Now this pound sign, this hashtag or number sign, whatever you want to call it, that only works in MySQL. Okay. It doesn't work in SQL Server. It does not work in Oracle. Okay, so if you're going to end up working in any of those database systems in the future, just keep that in mind. Okay. All right. So let's see. All right. So if I run this again, I don't think it's going to be a problem. Yeah, it's not going to be a problem if I run it again. Although, I ran it earlier to say to tell MySQL, hey, I want to use the school database. It's not going to be a problem. It's not going to be an issue. Okay. So I'm going to save this just for the sake of saving it. Use school database. Okay. Okay. So I'm gonna close that. I'm gonna create a new query tab. Okay, zoom in again, control, scroll down. Okay, so we want to create a table called students. All right. Now it's best that you not put spaces in the names of things. Just makes it easier to deal with down the line. All right, so create table students. Okay. As you can see, we can use the not if not exist and so on and so forth. And there's even a temporary option. I think we can elaborate that or discuss that later on towards the end of the whole session, the whole course. Um, but right now, let's focus on creating a table, something that's sort of useful or functional. Okay, so you might see books, or you might see me type the parentheses like this. You might see me type the open parentheses over there like that. Um, Bottom line is, you just need a pair of parentheses like so, and then towards the end you put a semicolon. Now, obviously, between these parentheses, you're going to need something else, okay? But at the basic level, that's what your create table statement would be composed of. Now, the next part, which is the stuff that goes between these parentheses, essentially, what do you want to have as columns? So if you look at the syntax, it says here create definition, and if you locate that in the syntax, it's right here. That section is further defined or further explained here, and you can put column name, column definition, and it says or you can add also these modifiers. Okay, so we'll tackle some of these later on. In fact, we're going to tackle in this example something's called primary key. But before that, let's put in the fields. So let's start with student ID. Okay, the student ID, as you can see, is a 6-digit number. Pretty straightforward, nothing out of the ordinary. So to define that column inside the student's table, we need to give it a name. Now, it'll be a problem if we call it like that. As you can see right there, boom, you get a wavy underline. My workbench couldn't even recognize that. So the name, don't use spaces. There are ways to get around it, but it's one less thing to think about. So if you don't have spaces, I'm gonna call it as ID. Hey Joel, you might ask, Joel, could we have used uppercase letters? Absolutely. But again, uh, depending on where you're gonna be using this database, you might need to maintain the capitalization, the letter case. So I'll keep it lowercase in my case, in my in my example. Okay, so I'm going to call it SID, student ID, and followed by the column definition according to the syntax right here. So where's the column definition? Okay, it's further elaborated down here. So let's take a look. Let's see. Column definition is uh, composed of the data type followed by these, so I guess, modifiers or settings. But what's a data type? Okay, the data type identifies what kind of information will go inside that field. And as you can see, there are tons of data types in MySQL. Other database systems usually have the same. They may differ in one or two things, but otherwise, yeah, that's the amount of data type we're dealing with in these database systems because there's just different kinds of data that you can store in a table. So let's take a look at uh, the details about this table. So let's open this in a new tab. Collapse that. Okay, so I can put here a data type of int, like so. Okay, you can use uppercase, lowercase, again, doesn't matter. But what's int? Okay, yeah, it stands for integer. So, um, looking at the table, well, more like the diagram. Um, the student ID, they're numeric. It's a six-digit number. So, they don't have letters. And let's say we ask the school itself, hey guys, will you have letters in your student ID? So let's say the folks there said, no, we're just gonna have numbers, purely numbers in our pure, just digits in our student ID. So if that's the case, you need to choose the right data type. Now, these are the different categories of data types. Okay, so apparently, because we're gonna keep the student ID as a numeric value, I mean, to be honest, we can keep the student ID as text. You might say, well, why text? It's composed of digits. Aha. There are times that you want to keep what seems to be numeric values as text. A very good example is the zip code. Why? Some zip codes begin with zero. In fact, where I live, the zip code begins with a zero. So, if you store that zip code, my zip code, um, let's say for example is 08103, let's just say, all right. If you store that as a number, it's not going to keep the zero in the beginning. It's just going to save it as 8103. So if you want to keep that zero in the beginning, you have to save that. You have to store that zip code in a field that has a string or text type. The term string in development is synonymous to text. It's actually short for a phrase string of characters, which is effectively text. So anyway, so we're going to use one of the numeric types, and in fact I did. I used int. So let's see what are the different numeric types. And as you can see, there's a lot. Alright, so even the integer alone, let's look at the integer types. Click. And different kinds: integer, int, small int, big int. So what are the differences? Okay, actually, they just differ in the range of numbers you can use in that you can store in that field. So for example, if the student ID was stored or had a tiny int as a data type, it says here I can store a number that's anywhere from negative 128 up to 127. Now, looking at the student IDs, they're six-digit numbers, and they're way beyond this range. They're way outside of this range of numbers, negative 128 through positive 127. Uh, yeah, so that's not going to be enough. In fact, if there's anything that can fit a six-digit number, that will be, well, the small int won't either. That's not sufficient enough. See, it's negative 32,768 up to positive 32,767. So medium int is actually capable because this one ranges from negative 8 million, so it's a seven-digit number, all the way to positive 8 1,388,607. Now, you can sort of, I guess, overshoot it a little bit. You can use the next bigger data type, or the next bigger data type. In this case, if we keep the int, I can have a number as tiny as negative, well, this is negative 2 billion 147,483,648, all the way to that number. Now, um, that's way above. That's well, well, that's big enough, more than enough actually, to store our student IDs. Um, in fact, big int is even an overkill. All right, so we can use int. I can, choose a medium int, but so you might say, well, why don't you just use big int all the time? But look at this column, it says storage. This is how many bytes of space each student ID will take up in the server where the database is stored, where MySQL is running. Okay, so if I have 10,000 students, which is that's easy in a small school. 10,000 students? Oh, yeah, that's easy. Um, that's 10,000 times 3 bytes. Okay, that's 30,000 bytes, and that's, you might say, well, that's only what, 30 kilobytes roughly. Yeah, but um, if you used big int, you would have ended up using 80,000 bytes, or roughly 80 kilobytes. So that's way bigger than the medium int. Bottom line is, you want to choose the smallest data type that will be big enough. It's weird saying in the same sentence. The smallest data type that's big enough to store the data you need, and well into the future. You know. So in this case, I can keep int. I can I can even dare go medium int. But I have something else to mention. So I in fact, what I'm gonna do is I'm gonna use medium int. Okay. But if we look at the reference, okay, so let's see, what's that right here. Okay, according to this, if I can put the medium int rather, um, and we can just skip the length part. But I can use another modifier here towards the right. It says unsigned. What is unsigned? Unsigned means that you're not storing, you don't want to store negative numbers. You just want to store numbers from 0 up to whatever. So for example, medium int will let us store, an unsigned medium int will let us store any number from 0, it says minimum value unsigned, 0 up to maximum of 16. Well, this is 16 million. So that's already, that's 8 digits all in all. So that's way bigger than the student IDs, the range of student IDs. So if like, there's no point of saying medium int here. Why? I won't have negative numbers. I won't have negative student IDs. Okay, so I'm not interested in storing negative medium ints. I'm only interested in storing positive ones, so from 0 up to 16 million point something. Okay, so SID medium int, and I'm gonna put here unsigned. Okay, again, you can type it in uppercase, it won't matter. So that's according to the reference. We can put unsigned, so we can just store, positive values, so to speak. But okay, so that's one field down. We got 3 more to go, but this should be very easy. So next is the first name. Alright, so since we're putting another field, so we put a comma here, then we can list the next field. So let's call this um, FN, like first name. Alright, now obviously names are text, so we need something that will let us store, oops, not this one. Actually, yeah, we need to use something that's text. So there are quite a few options. Let me bring you over to this tab, And let's click back and click back one more. So we're actually spoiled a little bit for choices. Let's see. It's still loading. All right, so let's visit string types. Okay. All right, so string types, we got the following choices. We got char, varchar, binary. Uh, I wanna talk about this, the char and the varchar. All right. Some of my students pronounce this char, varchar. Look, English is my second language, so it's up to you. I really don't care as long as you type the correct typesetting in your table, in your fields, okay? All right. Um, so speaking of which, you actually for the first name, last name, and the email address, that's right. We can use, well, which one should we use here? We use the char or the varchar? All right, it's actually very simple. Char, the char data type, it's fixed. In other words, when you use char, yeah, like for example here, char 30, you have to have, you must, not have, you must have 30 characters in the first name, which is the thing about it, it's ridiculous. You're saying that all students will have a 30 character first name. Of course, that's not, you know, that's a no-no, all right? So instead of using char, we're going to use varchar. Okay, it says here varchar columns are variable length strings. Okay, the length can be specified from 0 to 65,535. Okay, and effective maximum length of a varchar is 65,535 bytes. Okay, so in other words, um, it's a variable length, meaning if we say varchar 100, we can store up to, okay, not must, but up to 100 character first names. I don't know of anyone who has a 100 character first name, but yeah, that's the meaning of that setting. So obviously we're not going to put 100 here. So going back to our SQL statement, we're going to put fn varchar, but next to that in parentheses, and that's according to the documentation we got here. Alright, so we put varchar. Where's varchar? Alright, there you go. Varchar in parentheses the length. Okay, and we can set the character set and collation. But since we've already done that on the database, the setting, the collation setting, and the character set setting for this varchar field will just be based on the setting that we applied to the entire database. Okay. Um, Now, if you want that to specifically be different, then you have to explicitly state those. Okay. All right. So anyway, fn varchar, I don't know. Let's put 50. Now, choosing too little, let's say 10, that's not good because what if you store a student whose first name is more than 10 characters? So that's going to be a problem. All right. So you want to put a number that's not too small, not too big. You put a number that's too big, you're actually going to end up wasting space in the server. So for every student you're going to put there, for every first name, you're going to end up using more space than necessary. So I think I'm going to put here just for now, just an example anyway. So it's varchar 50, and we're going to do the same for the last name. So I'm going to put a comma, ln last name. That's not I, that's an L. Last name, varchar 50, comma, and we'll do the same for email. It's called as EML. Now, if you're asking, Joel, why don't you spell it out? I could, but I'm kind of lazy typing right now. So yeah, I'm kidding aside though. Yeah, you can spell out the field names if you want to, but bottom line is you just have to come up with a name. Okay. All right, so I called it EML varchar 100. The email addresses tend to be long from time to time. If you feel that 70 is enough, then or 75, hey, it's up to you. Okay, you make that call. All right. So looking at this, so we're actually ready to run this, but hold on. There's one setting that you have to put in every time you build a table, and that is what's called the primary key. The primary key, what it is it's a field, it's a column. Okay, so let's look at this table. So the primary key is a field. In other words, you just have to ask yourself, at least for now, okay, until we get to discuss normalization next meeting. Um, yeah, which of these four is what uniquely identifies a student in a school? I mean, the email address can be used, but in more often than not, in schools we use the student ID. Like you have your Hunter ID or you have your school ID or whatever. Um, yeah, that's what's used. Okay, so that's our primary key. Effectively, a primary key by definition is a field where the values are unique and that each value can serve as a unique identifier for each row. Okay, so how do we tell the server, MySQL, say, hey, we want student ID is the primary key. All right, so to do that, we put a comma towards, actually several ways. One of the ways to do it is you can put a comma here at the end and type primary key, okay? And in parentheses, you put the field, the name of the field that you want to serve as your primary key. So in this case, the SID or the SID, student ID, okay? Yeah, and that's about it. So we got the semicolon at the end. Everything looks good. All right, and I'm gonna go ahead and run this. But by the way, before I run it, why do we choose a primary key? Why is it a requirement? It's a required thing because database operations are based on the primary key. Internally, under the hood, so to speak, databases perform a number of math calculations, and that is true. These math calculations are based on the primary key. So if you don't specify one, you're actually not optimizing your database. You're actually hurting the performance of your database. I mean, of MySQL. In other words, not your database, your MySQL. So that's why it's a requirement. Okay, and there are actually a few other more technical, deeper reasons why you have to pick one. But I think along the way you're gonna see why. Okay. All right. So this is good. So let's run this query execute. All right. So we got a check mark. So it went through. Now I'm gonna save this. Let's call that grade table students. Grade table students. Should have called this grade two students table. Anyway, save. All right. So how do you know? How do you find out if this table indeed has been created? Now, of course, you can use this. You can go into tables, but I have another way. Okay. If you need to list your tables, there is. Okay. So, for example, you can type show tables. Okay. Let's run this. Let's just run that current statement. There you go. So when I typed show tables, remember we typed the use database. Or if you're wondering, do we have to type the use database? The use statement again. Like, do I have to type use school? Well, here's your answer. I didn't. I mean, I typed it earlier. After I run it once, that's it. You only need to do it once, unless you close this and you restart your computer, or you just close Workbench, you start over. Then yeah, you have to issue another use statement. But otherwise, while this is still open, while after you have issued that use statement, yeah, you can just keep using statements to create tables and whatnot inside your database. So like this one, show tables, that shows me a list of tables inside the school database. Um, just for the sake of doing it, I'm gonna create another table. Let me use another tab. Let me create another tab. So I'm gonna create another table. Create table courses. Now let's see. And put here course ID. Let's just put here car 6, and then course name varchar 50, and primary key course ID. Okay. All right. So let's say I have that. I'm gonna run it. Okay. So it created the courses table without any problems. Okay. Let me go back here to my other tab, the create table students, because this is where I have the show table. So I'm gonna run this again, just this statement. Okay. So I'm gonna put my cursor here. Click on query. Click on execute current, because that's the only thing I want to run. Look, now I have these two tables, the courses and the students. Okay, so in fact, let me get rid of this here. So I want to keep this intact and just the create table students. I'm going to close that. And this one, I'm going to save this as create table courses. Now I'm going to create another tab. So show tables. So I'm going to run that. There you go. So we have a list of tables. And I'm going to save this as show delete. Now here's why. What I want to do now is, let's say I made a mistake. I didn't mean to create the courses table. You know, like um, I want to do that over. I want to get rid of it. Okay, so all we need is, remember how we delete the database? So we use the drop database statement. So here you're gonna use the drop table, and then you put the name of the table you wanna delete, courses. Okay. Now just remember, once you drop the table, there's no way to get it back. In the same way, when you drop a database, there's no way to get it back. So you gotta be careful in running this statement. Okay. So I'm just gonna run this statement. Query execute current. Okay, seems like it dropped it. How do we find out? I'm gonna click here where the show table statement is, show tables statement is, and I'm gonna run just that statement. So execute current, and voila, we only have one table in the list. So indeed that dropped the table. Okay, now of course questions like, well, how do you change the settings of your table? Now we're gonna get to that in the future. In fact, not too far in the future, but in fact next week. But right now, your focus is on creating a database, creating a table, and performing those basic functions such as dropping them. Um, and also, I need you to focus on the data types. Make sure you study the data types well, because you're gonna make those decision calls later on as you're creating the database yourself. Okay.